So let's make sure we have the first one and this one, the one that we were doing last week also. What's up, thing?
I want to know what is going on.
You got that?
Babauta, what's
You got that?
Babauta, what's happening?
It's what we talked about on Friday. Well, then you missed the big news. Yikes. All right, so what did we do last week? Let's start there. Quick narrative recap. What were we doing last week, the last 2 days of class?
We're checking our water for anomia.
And what else?
Nitrite and nitrate.
And how do we test for that? In other words, what is it you actually did with all this equipment?
Also, basically, what we did was we took these strips from, I think they were like nitrates, and it was for nitrates and nitrate. How you say it? Nitrate. And we just dipped it inside the water, and whatever color we saw, that would represent how much nitrate or ammonia or nitrite was inside the water.
And what are these different three setups?
One is fish, one is plant, and the other one is bacteria.
And then what else did we learn about with the nitrogen cycle? Y'all remember any key words or ideas? The very last thing we were doing on Friday?
Fixation.
Okay, fixation. What was the other really important one? Something. Okay, we got one more. All right, so last week we had 6 groups. 2 groups each had either the fish, the plants, the bacteria. We were testing levels of compounds that have nitrogen in them. And we were looking at this as a model of the nitrogen cycle, potentially. So what we're going to do today is we are going to hopefully get through an entire mini design challenge. So we're going to call this Scientific Models Meet Design, and we're going to look at nitrogen. So we have a model of the nitrogen cycle that's in process, and we have some problems when nitrogen cycles are disrupted in the agricultural world that we've been talking about. So what I want us to do today is go through each one of these parts. So what are the parts of our design cycle? What's the first thing we do?
Empathize.
And then?
Define. Ideate. Prototype. Test.
So we're going to start with empathizing. What is the empathize mode? Stephen, can you read that for us?
Learn about the audience for whom you are designer by observation and interview. Who is my user? What matters to this person?
Awesome. So we are going to start off with a quick clip, and there's a short reading that goes with this, of a problem that people in Minnesota are facing because of something that has to do with a disrupted nitrogen cycle. So the only thing that I want you to be able to answer right now is the text, the bottom left-hand corner of the page. In this example, how do levels of nitrates affect Minnesota residents? What's happening to them because of nitrates in the water? That's it. This clip is very short. I think it's 2 minutes. So what is happening to these people because there are nitrates in the water?
in southern Minnesota are getting an update now on what's being done to stop the rise. KIMT News 3's Jaron Reddy joins us from Dodge County with more.
Nitrogen levels in water are a hot topic across the state of Minnesota, and the same can be said here in Dodge County.
I've been fairly involved with a lot of the water issues with different groups.
County Commissioner Rodney Peterson says there's been a lot of misinformation about nitrates in water, so he asked some experts to share what's going on locally.
I thought it'd be good to at least educate the board and use that information to the public.
Nitrates can be dangerous for infants from birth to 6 months because it can reduce oxygen supply in their blood. There have been a number of ideas tossed around on how to solve the problem, including Governor Mark Dayton's plan to add buffer strips between farmland and bodies of water.
I don't think that's the issue. It's not that we want a 100-foot buffer, 200-foot buffer, or a 10-foot buffer. The issue is that we want our water supply to be clean.
This isn't much of an issue for cities and other community water supplies because they're closely monitored. Instead, private wells are the issue. As a rural county, that impacts a lot of residents. But locally, they're seeing nearly 80% of the tested well water as safe to drink, and less than 10% have nitrate levels that are higher than they'd like.
It's been a concern of ours for a number of years, but it really helps now, or helps us now, to have the state agencies also be concerned about it, because we do kind of work together.
And right now they're working together on various projects like saturated buffers and wood chip bioreactors that will intercept the nitrogen runoff before it hits the water in hopes of bringing pollution down.
These projects we're doing are good, but we have to realize that to make a real effect, we have to use them extensively.
He says he's looking forward to seeing the numbers 5 to 10 years down the road to see how the practices they're doing now are working. In Dodge County, Jaron Rennie, KIMT News 3.
And according to a recent Minnesota Department of Health report, 75% of state residents get their water from wells.
All right, so what did we hear? That was so quiet. I know, I'm sorry, I can't boost the volume. What did we hear? This is a simple recall question.
Basically, this water affects babies from birth to like up to 6 months old.
Minnesota wants clean water supply.
Did you have the water was unsafe for like fishes?
Basically, 70% of the people get water from these wells, and then it's just basically polluting the water, and then it's messing up their water supply.
Awesome. Let's lead into quickly kind of the big question for this. Danny, can you read everything in red for us up here?
Nitrogen is a vital part, can't say this there, of biological and experimental systems, environmental systems. How might we use models of the nitrogen cycle to develop solutions to real-world problems caused by developed disrupted nitrogen cycle?
Sorry, that's my writing more than your reading. So we know nitrogen is important for the environment, for things that are alive, and we know there are problems that happen when the cycling of nitrogen is disrupted, such as harm to babies, such as just generally unsafe. Mickey, what were you saying?
It's just polluting their water supply.
So our quick empathy exercise is we know something's going on, and we have a real-world situation in Minnesota. And that situation in Minnesota is actually pretty common in areas across the country, especially if they are close to agricultural sites. So what we're going to spend most of our time doing today is seeing if we can use some of the information that we can gather from our models right now to think about how we might come up with solutions to that problem of too many of these nitrates or nitrites or ammonia, depending on the situation, in water. Okay. So we are going to jump right into a define portion. We're going to try to define this problem. So on the back of the first page. Elias, can you read that text on the left? How
How can we use our lab work from the previous 2 classes to define what problem might be for Minnesota residents? We know that nitrates are in the water. Why might this be happening? To start to figure this out, we will take one more data recording of our plant, fish, and bacteria stations from the previous week. By sharing the results, maybe we will spot a pattern.
Yeah, so like, what is actually causing this? What do we think the problem might be? So we've done this twice. I'm going to ask you right now to get into your same groups from last week. I want you to get, wait a second, you're going to get your little mini aquarium, and then you're going to run both of the tests that we ran last week. Once you get that information, you're going to put it up on the board back here. If you were not here last week and you have no idea what I'm talking about, come up to the front, please, so I can put you into a group. Hello. You want to be in fish, bacteria, or plants?
Bacteria.
Maybe bacteria? Maybe plants? Fish, bacteria, plants? You need the fish group, the bacteria group, or the plants? So the plants are the ones with styrofoam. The bacteria is the one with the colored pebbles, and the fish is the one where the small fish and the tanks. Yeah. So I want you to join a group. Preferably, I want you to join a group that only has 2 people here.
2 people in it?
Okay. Whoever's testing. Whoever's actually testing. Whoever's actually testing.
Okay. We gotta test so fast.
Whoever's actually testing.
Really quick.
Remember, in the vial first.
So fast.
We have to wait for the bottle.
Whatever you're gonna put in the water. Test tubes? Okay. Alright. It's okay. It's okay. It's okay. Did you dunk it?
That's what I'm doing.
Which one is this? Nitrate and nitrite.
Wait, hold on, I got
Yo,
3 seconds.
the second bottle.
And this one is.
Awesome. Yeah, thank you. So you want to do a modified version of this. Fill up water if you want to do this thing. But then someone's going to have to hold this.
You have to turn it on.
Okay. You get gloves? Do they give you gloves?
Well, we could throw this out, right?
Yeah.
If you want to do a modification here, you can fill this up with water. Okay, but you're going to have to hold it.
So just put 0 milligrams. So 0.
So 0.
All right, so once you start getting these results, you can put your test strips in the garbage here, and then please write up your results on the whiteboard in the back.
It's like that. The bottom one compares to nitrate, and the top is nitrate.
Like how to orient this? Is that what you're asking me?
Yeah.
So where's... So you compare it to this diagram. Tell me what you think.
4.4.
Are you gonna hold it like this? You can hold it upside down.
Oh, like this.
Yep.
Alright, so yeah, it's 2, and this one's like nitrate, yeah.
How long do you have to wait?
Nitrite is like,
Has it been 3 minutes?
I want to say like
Yeah.
0.15 or 0.
Hmm? So I'm the wrong person to ask for that because I don't have it. Who has that?
Alright. So it's basically, John is gonna get it.
About 30 seconds.
Flick of the wrist.
Yeah, it's still only the same. Yeah. Oh.
Time.
I don't know. Put the timer for 9 minutes. Yeah, 3 minutes.
Although you have 3 minutes,
What about
Piers?
the nitrate?
Almost. 3 minutes?
Good to wait.
So what is that going to be?
Alright, bro.
So where does it fit?
It is. I mean, it's already on the marks.
It's the Babauta. It's just that.
We'll just talk through what the actual test was. So what are we learning about the amount of water that we should use? How much water do you think we should be using here?
Oh, yeah.
Why do you think that?
Because you can't tell the color.
So if you feel like this is not an authentic result because you're not using the same amount of water as the first time, you can try it again, or we can wait till the other group is done.
Wait until the group is done.
Okay. So the same feedback to this group. What are we possibly learning about the amount of water that we use in this test tube?
That it's way worse. I think we just wait to go over it. That's usually safe. That's what I've noticed. It's been yellow for the past 4 days.
Yeah, no, not the first one.
Wait, no,
Like
this
one.
one. Yeah.
Let me see. For that?
Yeah, but the thing is, this is for. Because then it says pad near his handle.
Oh yeah, so this
So
one is
actually
0,
that tells you.
and this one is like
Yeah, I know.
right here.
Brandon, is your group done with the ammonia?
Yeah.
Tess, can you give that over to the fish table then? Because they need it still.
Oh no, it's opposite. This one's 0.2.
Then the 0.5.
Ideal. It's ideal, man. It's ideal. Bro. Oh, shit. 3 minutes is done.
We had to wait for the other two, for the other people to have finished.
You need this one. Anthony, you need this one? Maybe instead now. Yeah.
So it looks like you need to do the ammonia test, right?
Yeah, they're taking 3 minutes over there.
Are they supposed to serve your group? Have you gone over and gotten the material you need?
Yeah, we have this. We're just waiting for the tube. They said.
You gotta wait 1 more minute. Oh, we gotta wait 10 more seconds.
Alright, we got you right now, alright?
Right there.
Caution.
Right there.
We're caution today?
Yeah, caution.
Wow, we went down. Alright.
Do you need a tube for the nitrate test?
We can use this one.
Let me just answer the question that relates to us. Oh, yeah.
Mind you, so far, Aldo is the only person in the class who's put results on the board. Did you get the same result? Awesome. So then you have your own result. The fish group needs this though. So can you go give that to me?
That's just the numbers, right? But you gotta find the levels, right?
How you find the levels?
By the
It
little
tells you by under
thing,
the number.
which, you know, the green, yellow, that's
We did that already.
so
Yeah,
what you
but,
got. We're
yeah.
both doing plans.
Like when you check,
Do you still have it?
Nah, Jonathan took a look. Jonathan's over there.
Do you do nitrate test?
Yeah. Yeah.
So do you need to watch the water for your nitrate test?
no, only this. No, unchecks. Yes.
I pushed it. Yeah. I was right.
I don't know, it looks like a 5.
5?
Or like
Two.
like a 2.
Nah, 0.5, bro.
Like a 1.
Nah, bro, you are.
We good with these? Can we put these all back and put them up front, please?
It's like 0.5 is 0. So,
We got them?
yeah.
Alright. Did y'all get the nitrate test?
You guys got 0.15.
Yeah.
How you guys got 0.15?
You want to.
Wait, do we need?
Do we need
Put
a
it on
vibe?
top.
I don't think so.
Wow.
Looks like it's exactly the same.
Some yellow stuff.
Okay. Has it been 3 minutes?
Put a minute. And we wait like 2 minutes. No, we wait 1 minute.
What? What, bro? Okay.
All right, so we are just waiting for the bacteria group to finish up their nitrate nitrite test. Anthony, can you read for us the ID8 section?
Now that we have defined a problem, we can begin to ideate solutions using our laboratory models. This can be a complex task. First group would think divergently by considering a number of resources. What can we do with our lab models to solve our problems? Then groups will converge on a single solution.
Okay, so the next step of this is we're going to try to come up with solutions to a problem. but we're not quite sure what the problem is. What I'm going to ask you to do, once this group gets their nitrate and nitrite data up here, is to look at this data table. And then there are also 3 resources that I want you to consider as you come up with an idea for what you think the problem is that we're encountering here. So what is the problem that we need to solve? Once we have a problem for your groups, we're going to try to come up with some solutions. For this phase, the 3 resources on the back include some hyperlinked documents. So I'm going to put the Chromebook box on my desk. If you need a computer to access one of these, just come up and take one. Okay. One of the resources is also your last packet that we were working on last week that has a lot of information about the nitrogen cycle. So I want you to use a number of resources and this data table to think about what you think the problem is going to be that we're going to try to solve. Once you think you have an idea of what the problem might be, I'm going to ask your group to post it up front. This can be as a how might we question, or this can just be a statement. So what do we think is going on? How do you feel about that? It's open-ended, I know. If you look like you're really struggling, I'm going to come around and give you some hints. But for this one, I want you to know if you feel a little bit uncomfortable because you don't know what the problem is exactly, like we always talk about in this process, that's an expectation. That's what you're supposed to be feeling. So I may not give you exactly the kind of feedback that you want from me, but I may ask you to look at a resource, or I may ask you a question to help you clarify your thinking. But this isn't a time when I'm going to tell you that you are right or wrong, or that that's good or that's bad. This needs to come from your group. Okay? So Chromebooks are going to be right here. Yeah, it depends on how you're going to look at the resources. So some of you might want to use this. Some of you might want to look at the paper. What are we seeing here on this data table? What are we seeing? Like, what kind of information is that going to give us?
Somebody didn't sign
What does this mean? So I want us to start with our classroom information. All right. What do we think that might mean? What kind of information do we have? Are the different groups finding the same thing? Are they finding different things?
They're finding different
Why
things.
is it different? Why is it the same? What do we think might be a problem here?
Maybe the problem could be that
The water can be the problem.
So I want you to start with this.
guys, I think it's,
What is this telling you, or what
bacteria
is this
and
making you
fish
think
produce more
might be a
waste
problem?
rather than the plants don't. That's where there's like
You can use
higher
both.
ammonia.
Like, are they all the
than the
same? Are
plants.
they all different? Are some the same? Are some different?
Yeah, yeah.
Why might that be happening? What do we think is going on? Cindy, everyone should at least have a copy of that data table. I want you to start by looking at that. What's happening? Is everything the same? Is everything different? Some parts the same, some parts are different. Why is that? What might that mean?
Yeah, can you go? So while I get this set up.
Since you're saying that, can you go get me a computer?
Does one person have the data? Yeah? Awesome. So you need to have the data for everybody, right? Because if you don't, we can't spot trends. Okay, so I want you to start there. What do we notice about this data that we collected? Is everything the same? Is everything different? Something's the same, something's
Some are the
different.
same.
Why do we think that might be happening? And then also, for this group, when you think back to what we were looking at last week, is it a good thing? Is it a bad thing? Does it not matter if we have different levels of ammonia, nitrate, nitrite? How might that impact a community environmentally if this were their water supply? So these are the three resources that you can use.
Yeah, this one decreased and this one increased. And then that one stayed the same.
Yeah, but then now it went to 0.5. So like now it went to 0.15.
No, it started at, this is the day we started it.
Yeah.
And then this one is, this one was Friday.
Yeah, it was.
Because that was the other package. And this one is today. So it went back to 0.15. And so this one stayed the same according to today. And then this one stayed the same. So the nitrate increased, no, decreased and then increased again. And then this one just stayed the same.
For the plant?
Yeah.
For your group?
Yeah. We can't record today because this
Why not? Who in the class has that information?
the other groups.
Are you allowed to talk to the other groups?
I think so.
Yeah.
So what are we noticing with your fish tank?
Okay.
Has the data changed over time? When you compare these to last week, has anything changed?
Can I get you guys
Is it
data
different
for
than the other two tanks?
the past 2 days?
Oh no. Danny had the second there, I forgot to ask him.
Do you know if that's the same that is happening in other groups? So what can you do to fix that?
What does Z mean?
Because Yesenia also doesn't have information from the other groups.
And then what about the last one?
That's nothing, we split up and put it in one box.
Alright.
How's that on our second day?
Good move.
That on our second day we got 0 nitrite, but on our third day when I did this we got 10.
What do you ask to do?
That's classified.
Hey,
And can I get your data for past 2 days?
Since you have all the other data here, that's
well, based on what we looked at last week, this is where we're trying to find the problem. Why would a plant be producing
thank you.
ammonia?
Do you want to see mine?
yeah,
Would we expect it to be producing
It's just
ammonia?
the first two.
Would we expect it to be producing nitrates or nitrites? What do we know about the plant's role in the nitrogen cycle? To answer that question, I'm going to redirect you to what we were working on last week and those other two
It said that on the
resources.
chart?
Aldo, what do you think of
So you couldn't find that one? The data?
the plants released that?
Alright.
Are you sure?
Alright, so I got the data from
Thank you.
the two groups. Can I copy it?
Well,
There is
So you're describing the cycle. I'm going to ask you if this is part of the cycle, or if
This
they're
one
just
just
independent
decreased.
pieces of the cycle.
And this one is just kind of scattered. It went from ideal to cautious to ideal to.
Because you just said that
I
there's
guess
bacteria,
stress
there are
means
plants,
cautious.
You said there are animals. Do we have all of these things here, or
The
not?
ammonia is probably in the
And if,
danger zone.
and if we don't, what would we expect based on that one piece?
Yeah, because
That's,
it
I think, the
stayed
first question, the
ideal,
first
and then it
resource.
went to cautious.
So if you have a tank that's water and that bacteria that we added to it, what would we
Probably
expect
constant.
to be produced, if
Which
anything?
one's the last one? Stress?
Yeah.
Hmm?
And then the nitrate.
Just use someone else's round.
Wait, I would put constant for that one because it stayed 0.2
So in your,
the same.
Kathy, I want you to relay this to your group. Ask you a couple questions. In your plant tank, right? What was produced here? Okay, when we look at what was produced, I want you to think about how that information changed over time. Like were the measurements different from day 1 to day 2 to today? And then I want you to look at what you would expect to be produced by a plant in water like this. Alright. And then I want you to think about what role your plant could have in some sort of problem that we're trying to articulate here. What information do you have about the role of the plant in the nitrogen cycle? And think back to the Minnesota residents. Like, what's going on there? Why do they have so much of the nitrates in the water? And what can we help you? So, what does this data tell you? How is it different? How is it the same? And does it match your expectations? Right? So for that, you're going to have to go back to your previous example.
So packet 1.
You're going to have to do that. Especially how it's changed over time, if at all.
You'll bring in Steve and you'll see that.
Yeah, because everyone started with ideal.
Yeah, because we didn't pour anything into that beforehand, so that should be ideal for
For
the first
fish?
shade.
Which value changed the most for the fish here? The ammonia? Jose, did you get that too? That in your fish tank, there's a lot of ammonia produced?
But it's still good. It's still good.
So why do we think that there would be a lot of ammonia in the fish tank? And what might that mean if we think about this problem that we're looking at the beginning of the class? Like there's a lot of ammonia in the water. Is that a good thing or is it a bad thing in terms of impact on the environment?
It's a bad thing. Believe it's bad.
I believe it's bad.
Do you have some evidence that would lead you to conclude that it's bad? Can you show me where that evidence is?
Use your data.
And if you think it's bad, I'd like you to consider that as possibly a problem to define on board.
All right.
Why don't they have like names and numbers?
If you want to translate them, you know how to do that. Right?
Just check.
So Jasmine, the testing kits are front. Do you want to translate those? So what do we find out? Anything? Is your plant tank unique in any way?
The plants are likely to have less ammonia, nitrate, but more nitrate and more nitrate.
What about compared to the other groups?
That's the least out of all of them. So the ammonia is like the solution is to have more plants or to have less.
So what's the problem then? instead of jumping right to the solution, what do you think a problem might be?
High levels of ammonia
And what?
in bacteria and fish. Because both of them are caution, while ours stay ideal for like the rest of 3 days period.
So do you want to be trendsetters? That'd be awesome if you could write that down. You think that's a problem? Sounds good to me.
I just can't like write my idea though. I just forget them.
That's where Fabian and Anthony come in, and they can help you with that. You can all go out together. What have we noticing about these tanks? We have a problem?
Nope.
Something? What conclusions have we drawn from looking at our data? What's different? What's the same?
You guys are right for me?
Can we rephrase what we said? I mean, can you say? Can you rephrase what you said earlier? So I can write it.
Plants are most likely
Plants are most likely to.
Everything's high.
Right here, right?
yeah.
Data we took it was caution, the nitrate are high. We're kind of in the middle because they depend on the other two. Bacteria depend on the plant, the plant depends on the food.
How could you rephrase that as a
Most
problem?
likely to.
To have less.
To the left.
Oh, damn.
To less than the ammonia and nitrate.
You think that's a problem?
Less ammonia.
Less ammonia.
Yeah.
Sounds great. Let's get it up. We have a problem.
Ammonia then what?
And bacteria.
What do we think? What's a problem? What about their waste? So you think there's a problem because the fish are producing a lot of ammonia? Sounds great. Let's get it up there. You looking at the aquaponics?
Yeah, I determined the statement for the data. It's just basically saying that the level of ammonia is high, so it's just entering the danger zone because it keeps on bouncing around. Because it stayed ideal and then it entered the caution zone and then it stayed ideal.
Do we think that's a problem?
Yeah.
Write it up there.
Yeah.
Feedback I'll give you is your problem sounds very similar to other groups' problems that they've identified. So I think we're at least agreeing with each other. That we're noticing a similar thing in all their data. So let's get that up there.
Okay.
All right, folks, I'm going to pause in about a minute. I've discussed your noticings, and it seems like everyone is more or less converging on a very similar problem statement or problem area.
Alright, you got this? Yeah. Okay. No. Going back. Don't worry about it.
It'll be in the library. 3D samples. I think our definition.
All right, so we began this little exercise by considering a hypothetical situation, right, for our class, that we are going to be investigating a problem that's happening in water, and we have a real-world example from Minnesota where we have too many nitrates in the water. They're affecting the health of the public, and it's a serious problem. We just looked at some data that we collected from models of the nitrogen cycle that we are trying to build, and we came to some conclusions, and we think we have some idea of where the problem might be. So if you wrote something on the board, can you please just read that out for us so we can know what your group's thinking is?
Plants are more likely to have less ammonia than bacteria and fish.
fish have more ammonia due to the waste they produce?
How might we decrease ammonia in fish water?
You say it one more time?
How might we decrease ammonia in fish water?
Same thing.
The high levels of ammonia is affecting the environment and the growth of the plants.
All right, so thinking of these potential problem areas, we are going to do a rapid 2-minute brainstorming session. A lot of you have already begun to look at some of the resources provided. Okay. So how do we think we can solve this problem? And after we do this, we're going to try to prototype some solutions in our room. So what can we do about this? Okay. How do you think we could solve this problem? When that big hand gets to the 9, we're going to share out what you think we're going to work on. Okay, how can we solve this problem? What do you think is going to work?
Prototype, right? You want prototype? So, how do we solve this? The fact that there's more and more ammonia to be cautious than there is planned. What do we think?
This is materials up here.
So we can like use those materials to create like an experiment in some sort of way to test.
We could. What kind of experiment would you want to create? That's what we're trying to articulate. So I see a lot that we have too much ammonia, we're missing some things. That ammonia is destroying ecosystems potentially. What can we do about this? We got too much ammonia in the water, or too much.
Use fishes that produce less waste. Less waste means less ammonia.
We're going to. So, how do you think we're going to fix this? What needs to be done?
The ammonia levels have to be like on the same.
How are we going to change the ammonia levels?
Since the ammonia level for plants are ideal, it can be like
We put these two. We put the plants in with bacteria and fish environment and see what happens.
Does that make sense to you?
We could reduce the population of fish, bacteria. So it could be
What do you think we can do?
I don't know.
Looks like you're Googling it, which is unfortunate.
I think we should test like the plants
Well,
and
what
fish
could we
and
do?
bacteria.
In class, we have
Wanna
models.
see
What could we do to
containers,
see if we can fix this
if
problem?
anything changes over time.
that's what we've been doing.
But these are like separate.
Like find something
Yeah,
else
sit together.
and replace it.
Maybe.
Together.
Yeah.
That's gonna be even more worse.
Like, you
There
know,
might be a
to
change about it.
find out
change anything.
why we're using it and try to replace
When do we
That's
use
what we're
ammonia?
trying to see if it does change over time.
But it won't.
that.
Like it'll just make it worse.
It increases the
Do you
change.
know?
Nah, I don't know. It's just a hypothesis.
I think it's worth a try.
It's a worth an experiment.
Yeah. I mean, we're not hurting the whole population of like the country or something. We're just like testing it out.
What are you thinking?
But yeah, I think we should try it.
That's my
It's
like.
this question.
Whereas like
Yeah,
if you
how
put
can
two
we fix this problem?
caution ammonia
Your group is
together,
telling me you got too much ammonia. How can we?
We
just
should put,
changing that.
Control.
we could put, we could put more in deal than fish.
Well, the only ideal in ammonia is plants grow. Plants don't
Aquaponics one?
hurt us.
All right, let's hear what you got, group by group.
Do we have?
Oh,
Danny said to make like a complete nitrogen cycle, like put every factor in it, like the fish and the plants, because they might depend on each other.
What do y'all think?
Not the same, but I thought that to have like plants be with bacteria and fish, and see what are the possible outcomes.
We can decrease the use of modification, so we could just stop the process altogether.
Put filtering systems inside the tanks.
What is aquaponics?
Aquaponics is a cycle basically using fish to help the environment, and the environment helping the fish as well.
So for all these solution ideas, I'm gonna put constraints here. So we're gonna try to prototype a solution idea right now. Actually gonna make something. This is your constraint. You can use the materials that we had last week, and up front, I also have some plastic tubes, some foam blocks, some submersible pumps, some masking tape, some binder clips, and I also have some sharp scalpels and scissors that I can use if you are someone who for some reason wants to cut part of the tank or something else. Okay. I will review this one point for all of you as you're starting to think about your prototypes. The most common idea in the room, which doesn't mean it is the idea that is going to work the best, is some variation of aquaponics, right, where we're mixing the plant and the fish and the bacteria tanks. Nikki, if you want to do something about reducing ammonia somehow, you're welcome to explore that. And if you want to think about creating some sort of filter, you are welcome to try to do that. But the constraint is we just have these materials and we have your tanks. Before you build anything, I need to see a sketch of your idea, and I need you to tell me what you intend to do. Okay. So the first thing you're going to do is develop a prototype on paper, a two-dimensional prototype that you're going to draw out before you start working with these materials. Exactly. Of course, if you're sketching, you're free to come up and look at these materials. I just don't want you actually building anything in. You're free to come up and grab and look. So you got materials up front. Also, all the stuff on the desk we can use. So if you feel like collaborating with another group or other groups is going to help you with your prototype, you can do that. Right, so you could have more than just your tank.
You want to what about you said? Put the things together.
I think we're gonna. We could. Yeah, we could.
Alright, so we
Because look,
create a
the
freaking
ammonia's in
this
there,
as a
right?
fish tank?
We could get the ammonia out of the pump either through the side or over the top. I think through the side. No, through the side. So then
Like to throw
we get
everything
all
into
this
this?
stuff, right? It would have to go into like another container, like a bottle or something, and we could put the foam in the bottle, right?
What about the tube? Where's
The tube's gonna come on top of the bottle like that, and then on the bottom will be the filtered water, and then we have to cycle that back in.
Looks good.
Okay, but what about the pressure for the water to come in?
We have there's a pump.
You got a pump. There's a water pump you can use. Also, I just want to remind you, it's not just a step up front. If you want to use other tanks in the room, you can also do that. So you can join forces with another group or groups.
Alright, get a pump, get a couple tubes.
Yo, John, come on, we're gonna go get a pump.
Wait, we're doing this now. Get a pump, 2 tubes, alright, and the styrofoam.
They're gonna die.
It was the pump. We need another tool, so we need to combine.
Could be. Remember, we're not building quite yet.
Ideas, alright, ideas. Let me see this.
Grab the pump, grab the tube. Grab, we got the tube. Got a full.
We're going to show this up. All right, folks, we are coming up against a time boundary. So in the next 30 seconds, I would like you to please return to your tables. And how we're going to end this is we're going to just do a rapid publication. I want you to talk about your prototype design as it is right now. What is your thinking? When we come back in class, we will build these and we will start collecting data to see if our prototypes are effective solutions. Ashley. Jordan. Pause. All right, so this is exactly when I probably should not interrupt your process, but because of the way the school is scheduled, we must stop right here. What I want us to do, group by group, is just give us a quick 15-second idea of what your prototype is going to be, you think. What are you thinking?
We're pretty much going to have like the fish tank, and we're going to like divide each section into like 3. So one will have like its own plant, bacteria, and fish. However, we're going to connect each of them via a tube. So technically, it's its own individual, yet it's still helping each other, and we're going to test each of them individually.
Our prototype is to have like our plants at the top, and under the bottom we could possibly have fish or bacteria, and there's a tube coming out from under the water to the plants.
We were thinking about creating a model that was similar to the video that you showed us. It relates to ammonia and how we're trying to stop the process of ammonification.
All right, then. As of right now, our idea is we're going to submerge the pump into the tank, and we're gonna have the pump filter out into another container, like a bottle, like a water bottle or something. In that bottle, we're gonna have one of the foam, and we're gonna use it as a filter to catch the ammonia. It's gonna drip into the bottom of the bottle. Then we're gonna somehow figure out a way to get the water from the bottom of the next container back into the tank.
You're doing the same thing. All right.
Actually, we could use like a bowl. You never thought of that, like a tank? Instead of using a plastic.
All right, folks, when we come back, we are going to start off by... Guys, folks, wait a moment. When we come back, we're going to build these prototypes. We're actually going to build physical prototypes. We're going to have a baby shark tank where we give each other feedback on what works and what doesn't. We're going to have a final product that we're going to test for 4 days. Awesome work. Please put the tanks back where you found them and the computers back in the box. You can try to connect with other groups.
I don't think I saw that.
I said. Yeah, give us like 30 seconds. Because we have a lot of material to go with it.
Oh.
So this weekend, I want you to think about using the emotive filtering through the phone. I want you to think about how big ammonia is and see if that makes sense. Alright, so I want you to look that up, research that.
I was
Can
just
you?
saying as an idea.
No, I know, and it's an awesome idea. I want you to research that. Like that is a feasible idea. How would you filter ammonia? What is what you're proposing to do?
Oh, alright.
Sing it.
The video that you showed us.
Which one?
The ammonia video.
In Hawaii. The one in Hawaii.
The system with the guardrails.
Yeah.
So if you're gonna reduce ammonia for a plan, we need to have more specific details about how you're actually gonna structure that. Ooh.